Hey everyone, Fred here, AF Math and Engineering. We are taking a look at force system resultants. Okay, so what that means is we have a beam here. Okay, this is kind of first year strengths one, mechanics and materials stuff, basic stuff. So we're going to take this beam that we have, and the beam is simply supported here. We have a roller and a pin on either ends, and we have two different loadings here. Okay, so we have a rectangular loading and then we have a triangular loading here. And what we're going to do is we're going to create a single force. We're going to resolve the force of these two loadings into a single force at point O and a resultant couple moment. So let's go ahead and let's get started with that. So let's take a look at the question. Always, we're first going to read the diagram, and we are going to observe that we have a roller here support and we have a pin support here. Okay, so in this question, honestly, that's not really going to make a difference. All right, we are just going to resolve the external loadings. Okay, but it's good to take a look at what's going on in the question and just think about it and see if we need that information. But in this question, we aren't required to use those. So let's go ahead and let's take a look and see what we need to do here. And as we can see, the first thing that we're going to need to accomplish is we're going to need to draw our free body diagram. Okay, so like I said, we'll just read the question first. Replace the loading by an equivalent force and couple moment acting at point O. Okay, so for the first thing we're going to do is we're going to find the equivalent force, and I'm going to draw my free body diagram. Okay, and we have our 4 meters here. Okay, so we have 3 meter distance here and a 4 meter distance here. And so let's work with the rectangular loading first. Okay, so we have a distributed load from the point O here. So this is our point O here. Okay, and we have a rectangular load that spans from here to here. All right, so whenever we have a rectangular load, what we're going to do is we're just going to multiply the distance that the rectangular load spans by the force per length unit given. Okay, so here we have 300 newtons per meter. We're going to multiply that by 4 meters, and that's going to give us the single point force. Okay, now that's pretty simple here, right? All we need to do is multiply 300 by 4 meters, and we're going to get 1200 newtons. Okay, but where does that force act? Okay, so for a rectangular load, the force acts in the center. Okay, so essentially it acts at the center of gravity of the force. So for just for a rectangle, the center of gravity is going to be right in the middle. Okay, at 2 meters. All right, so it's going to be acting right here. Okay, and that's going to be 1200 newtons. All right, and this is 2 meters, and this is also 2 meters. Okay, so it's acting at the center of gravity. Perfect. Let's go ahead and, so we've resolved the force for the rectangular load. Let's resolve the force for the triangular load. Okay, and all we have to do is find the area of the triangle, okay, like we did for the rectangle. Okay, so as we know, the area of the triangle is base times height divided by 2. So the height of our triangle is 300 newtons per meter, okay, our force per unit length, and our length of the triangle, or the base, is 3 meters, okay, so that is going to be, we're going to have 300 times 3, which is going to be 900 divided by 2, so that's going to be 450 newtons. Okay, so we have 450 newtons. Now, the center of gravity for the triangle, okay, acts not in the center, right? It's not just going to be right in the middle. It's going to be a third of the length from the height, or from the tallest point here. Okay, so it's going to act at 1 meter or 2 meters from the roller support. Okay. And that's going to be a 450 Newton force. Okay, so we've drawn our free body diagram. We've outlined all our distances in between the forces here. Okay, so let's go ahead and let's finish with the question asked. Okay, so we're replacing it by equivalent force. All right, so we're going to say, okay, the force is in the y direction, and we're going to use up as positive, is negative 1200 newtons minus 450 newtons, right? Because they're both acting downwards. And that's going to be equal to 1650 newtons, okay? Negative 650 newtons, or if we can, we'll just go ahead and rewrite that as 1,650 newtons downwards. And that is our resultant force. Now, we've done other videos on resultant forces and couple moments, okay? And we have to take into account the moment created by these forces if we're translating this force to point O, okay? So if we take these forces and we move them to point O, we have to remember that these forces were also exerting a moment on the beam. And we need to include that moment at point O, okay? So let's go ahead and let's just use our basic moment taking skills in order to resolve the moment at point O. Okay, so if we're at point O, we have this 2 meter distance to the 1200 Newton force, okay? That is going to be in the, and as we've dictated here, okay, counterclockwise is positive here, and this is in a clockwise direction for the force here, so that's going to be negative. Okay, so we have negative 1200 newtons times 2 meters, okay? And let's go ahead and take a look at the 450 Newton force, same direction, clockwise, negative, 450 newtons times, and how far is that one away? Well, that's 5 meters, 2 plus 2 plus 1, 5 meters, okay? And what's that going to give us? Well, we have negative 1200 times 2 minus 450 times 5, which is going to give us a moment, the sum of the moments, okay, and is going to be negative 4,650 Newton meters, or we can say that it is 4,650 Newton meters in the clockwise direction. And that's it, we're done. Okay, so that's what we've arrived at for our final answer. We've found the resultant force of the loading on the beam, and then we also found the couple moment. Okay, so don't forget that, Whenever we're translating forces, we need to include the moment as well. And that's what the question asked for, so that's what we did. Thanks for watching, guys. Appreciate that. Hope this video helped. Like and subscribe if you enjoyed it.